This short video is an example of my case study of a metabolic equation. And just to review, here are the conversions that we've seen before and you are starting to remember. And I'll use most of these conversions actually in my example of a case study. And also to review, and this is just taking these conversion numbers, or most of them at least, and making this nice little flow chart. And depending on what you want to do, you can follow the different arrows. And remember that the case studies, if we're solving for VO2, we're solving for milliliters of oxygen per kilogram body weight per minute. And I'm going to use a case study, my example of the case study, we'll use the walking equation. So the walking equation is VO2 is equal to 0.1 times speed plus 1.8 times speed times grade plus 3.5. And here, speed is in meters per minute, so we'll need to convert. Grade is in a decimal form. The resting component is typically 3.5 mils of oxygen per kilogram body weight per minute. And those are the units for oxygen consumption. So they're relative units relative to body weight. So here's my case study. And my case study involves Dr. B1. So Dr. B1, he weighs 180 pounds, he's 72 inches tall, is a professor of kinesiology at a Central New York university. When the weather is nice, Dr. B1 likes to walk with his colleague, Dr. B2, and they go at lunchtime to the local Burger King fine dining restaurant. They depart from and return to the Student Life Center, and it takes them about 30 minutes to walk to Burger King. Other colleagues, Dr. H1 and Dr. H2, they tease Dr. B1 about his lunchtime walks, although maybe they would actually like to be invited. Calculate the approximate energy expenditure in kcals of Dr. B1 lunchtime walks, and then what would be the total caloric expenditure if you added in Dr. B1's lunch. So there's the case study, and then let's see what we need to do. So first of all, we need to determine if it's a walk, run, or a bike, and I told you that this was going to be a walk equation, and that was mentioned in the case study as well. So he's walking to Burger King. So that equation is 0.1 times speed plus 1.8 times speed times grade plus 3.5. And then we need to convert some things. So we'll start off by converting his body weight in pounds into kilograms. So it's pounds divided by 2.2. So Dr. B1 weighs 81.8 kilograms. But we also then need to know speed, and we also need to know grade. And grade is actually going to be easy, and grade is 0. So there's no difference or no change in the elevation going from the Student Life Center to Burger King. So it's pretty flat. So we're just going to assume it's completely flat, so no change in elevation. So this whole part of the equation is going to be 0. So anything multiplied by 0 is 0, so we can just X out that whole part of the equation. So we figured out grade, but then we need to figure out speed. So I did some math, and I actually did some map. And so we're going to go from the Student Life Center, and we're going to walk all the way to Burger King. So there's that shortcut you can take over the creek, and Burger King is in that shopping center by Coffee Mania. So this trip is 1.3 miles in distance, and as Dr. B1 mentioned, it takes about 30 minutes or 27 minutes. So we know the distance, and we actually know the time. So we can use that then to calculate out speed. So here's my notes of how to calculate speed. So if it's 1.31 miles in 27 minutes, well, we would like to know what that is in miles per hour or miles per 60 minutes. So you just do the cross multiplication game. So it's 1.3 times 60 is equal to 27x. 78 is equal to 27x. Divide both sides by 27. We can cross out the 27s. So 2.9 is equal to x. So that means it's 2.9 miles in 60 minutes, since 60 minutes is an hour. That then is 2.9 miles per hour. So that would be the speed. So then we can go back into our PowerPoint, and the speed is now 2.9 miles per hour. Oh, but wait, remember we need to convert. So we need to convert miles per hour into meters per minute. So that's simply multiplying by 26.8. So the actual speed in the equation is going to be 77.7 meters per minute. And now we're just going to solve for VO2. So here's the equation. VO2 is equal to 0.1 times speed plus 0 plus 3.5. So 0.1 times 77.7 plus 3.5, or 7.77 plus 3.5. So his VO2, if he wore a portable oxygen analyzer walking to Burger King, he'd be consuming 11.27 mils of oxygen per kilogram body weight per minute. So VO2 is reported as mils per kg per minute. So I guess we're done with the case study. Let's look again. Calculate the approximate energy expenditure in kcals of Dr. B1 and his lunchtime walks. So now we need to follow this conversion flow chart. So we're over here on this side of this conversion flow chart, and I'm asking for calories over here. So we've got to follow this part of the pathway. So multiply by body weight, divide by 1,000, multiply by 5, and then multiply by the total time to get total kcals. So I think I did this as well on a different piece of paper. So we have 12.7 mils per kg per minute. So multiply by body mass. So multiply by 81. Kilograms cancels out. That is equal to 921.9 milliliters of oxygen per minute. Divide by 1,000, or move the decimal place over. It's 0.921 liters of oxygen per minute. Then multiply by 5. It's 5 kcals per each liter of O2. Liters of O2 cancels out. So that's equal to 4.61 kcals per minute. He walked for about a half an hour. We'll use the minutes we found online, or 27 minutes. So multiply by 27 minutes. Minutes will cancel out. So that's 124.5 kcals walking to Burger King. If he's coming back at the same speed, just multiply by that 2, or multiply by 2. So that's about 250 kcals total of walking to Burger King and then walking back from Burger King. So then what would be the total caloric expenditure if adding lunch at Burger King? And I also looked online for some Burger King, how much kcals, how many calories are in Burger King food, and there's a lot. So let's just say he eats a triple Whopper sandwich that's 1,220 kcals. He gets some onion rings that are 500 kcals, and a Coke that was, where was that? Here's a Coke that's 390 kcals. So if we added all of that up, a lunch total calories of a Burger King lunch is 2,110 kcals. And it was only 250 walking to and from kcals walking to and from Burger King. So obviously they're not equal, and we would recommend Dr. B1 not eat this big caloric lunch, and maybe walking to and from Burger King is a great idea, but maybe eat, if he wants to eat at Burger King, they actually do have some salads there, um, or maybe take a walk and eat, a peanut butter and jelly sandwich or something in his office. So this was my example of a case study using the metabolic equations. I used the walking equation, and I'm excited to read your case study examples that you submit for this laboratory portion of our class.